This instructional video is designed to show you how to do the math with significant figures and retain the appropriate level of accuracy upon doing addition, subtraction, multiplication, or division. There are two rules to follow. The first one, obvious and straightforward, is to do the math. The second rule is going to require you to use rounding and your knowledge of significant figures. So you will round to the least accurate. And so by being able to tell what number has the fewest sig figs, which one is the least accurate, that is what will help you figure out the appropriate number of spaces to round off to. So let's start with something straightforward. 35 times 2. So 35 times 2, we do the math, which is the first step, that's 70. And now we need to round to the least accurate thing. That's going to be the 2, because it has only one sig fig. In order to represent this with one sig fig in an unambiguous way, we can use scientific notation. So we will just have the 7 times 10 to the 1. Let's try one with division. 22 divided by 2. 22 divided by 2 is 11. And because the 2 has only one significant figure, this becomes 1 times 10 to the 1. And the philosophy here is that we can't have something more accurate than the least accurate part of the original calculation. So a third example, let's do 12 times 9. For those of you playing along, that is 108. And because the 9 has one sig fig, this one will come out as 1 times 10 to the 2. Let's look at that from an example that is perhaps not as simplistic as these. 12.0, because of the trailing rule, we have 3 sig figs times 3.00. We now have 3 sig figs here. So that gives me 36 from just doing the math. However, because both of these have 3 significant figures, if I'm writing this in scientific notation, I would have 3.60 times 10 to the 1. So that use of scientific notation allows us to really retain a lack of ambiguity. We have more precision in how we use the language. So those are examples using multiplication and division. Let's do a couple of examples using addition and subtraction. So first up, let's do the following. 120 plus 1.5 minus 0.4. So step 1 says do the math. So if we add all of this up, that's 121.1. And now we need to consider what's the least accurate thing. 0.4 has one sig fig, but that's in the tenths place. 1.5 has 2 sig figs. 120 only has 2, and that 2 is the least accurate thing, which means that this number is only accurate to the tens place. So this can only be accurate to the tens place. And if we write out the answer in scientific notation, that's 1.2 times 10 to the 2. And that is because, according to this rule, this is our least accurate thing. Now let's take another example. 14,561 minus 61.00. if we do the math, that's 14,500. And we want to figure out how many sig figs we have remaining. So we know that the 1, the 4, and the 5 by the first rule of sig figs are themselves significant, but how many zeros do we have trailing? Well, the least accurate thing is in the ones place. So because this is the least accurate part of the measurement, that is where we stop. So this last zero is itself significant. That means that we need 1.4500 times 10 to the 1, 2, 3, 4. So by following the rules of doing the math and rounding to the least accurate thing, it is possible to complete any basic arithmetic operations using significant figures.